Hey Baltimore County families, my name is Miss Bond.
And I'm Mr. Bond.
And we're the Science Guys of Baltimore. Thank you for joining us and Baltimore County Public Library.
Today we're going to show you 3 ways to make volcanic eruptions at your home. Don't worry, you'll all be safe, but your ceilings may be a different story altogether.
Let's do it.
So, for our volcanic eruptions today, I figured we'd start with the classic, and that's baking soda and that's vinegar. You put them together, you get carbon dioxide gas that comes out, but we're going to do a little bit of a spin on it. We're going to do it this time with our red balloon, and we're going to add our baking soda in. So why don't you go ahead and put about 5,
inside the balloon.
5 milliliters inside, yeah. Rather than just dumping it in, we're going to put it actually inside of this balloon, right? Good. Maybe a little bit more. Try not to rip it. Perfect. Now, the next step, we need just about 100 milliliters inside of our container. And for you at home, that's anywhere. You could add a 1/4 cup or about a 1/2 cup. This is really not that exact of a science. Obviously, we want to just go ahead and get the reaction going as quickly as possible. So now the last step, now that I have vinegar in this and baking soda in my balloon, now I'm going to put it on to my container. Now this container is kind of a small mouth, so I can fit my balloon over it. If you have like a water bottle or something, that might work really well. Then the last step is I'm going to pour all the baking soda all at once into my container. Now if we're lucky, I'll be able to get all the baking soda out and into the vinegar, and we'll catch all that gas inside of the balloon. Here we go. 3, 2, 1.
Oh, nice.
Oh!
Look at all that gas being.
Wow! You guys, that is filling up the balloon like crazy. That gas is carbon dioxide coming off really, really fast and filling up my balloon. And I can feel it already. I feel that's really, really heavy. I have a feeling this is much heavier than, than a normal balloon. Now, we're going to tie this off. I've got trapped pure carbon dioxide gas. Normally the air is something more like nitrogen and oxygen. And I'm going to blow up a separate balloon about the same size with my mouth. Try again. Now, as I blow that up, it's about the same size, right? So you would guess they're about the same weight. Well, my friends, nothing could be further from the truth. This is actually an experiment I love to do. One of these has nitrogen that I breathed in and put back into the air. The other one has pure carbon dioxide. Which one do you think is going to be heavier? Everybody take your guess. Here we go. I'm going to drop them at the same time. Do you want to drop one and I'll drop one? Here we go.
This is the balloon you filled with your
With my air,
okay.
Nitrogen, a little bit of carbon dioxide. This is pure carbon dioxide. Let's see which one hits the table first. 3, 2, 1. If you notice out there, we'll do it again. If you notice out there, the carbon dioxide balloon is much, much heavier in this case. Let's go from a little higher even. 3, 2, 1. Every time that carbon dioxide filled balloon falls down almost immediately. You okay down there? Now, there is an even cooler eruption that we can do using pretty much household chemicals. You may have seen this at home. This is called hydrogen peroxide. We normally will use it to clean our cuts. And then what we're going to use to start the reaction is we're going to use some yeast. Now, I'm going to have you go ahead and open that up, and I need you to pour it inside of our cup. So you go ahead and add that inside there. If you're doing this at home, it doesn't matter what kind of yeast. We have active dry yeast here today.
Active dry yeast?
You might have seen yeast. Yeah, we're pouring it out. Yeast is a lot of times made for making bread. It's actually a living organism. We use this in our bread making, all sorts of baking, and it smells in the room a little bit like Cheerios, if you ask me. Now, the reason we use it in baking bread is because it adds air. It's going to be a similar experiment to what we saw with our baking soda vinegar reaction. This is going to, once it starts to react with our hydrogen peroxide today, is going to create pure oxygen. And we want to catch that in something too. So now that we've added our yeast particles here, we want to add some water in there. Will you just pour a little bit of water just so it's just over the top of our yeast? And you'll go ahead and do this at home too. Just add that water, fill it up, and what you notice almost immediately is it starts to smell like something. Now he's going to stir it up really, really well. While he stirs, I'm going to come over here and grab my board because I'm going to teach you something. Once we start, we'll have H2O2. That's hydrogen peroxide. We're going to do a reaction that makes H2O2 turn into H2O, which you all have probably heard of before, water. It'll turn into water and a little bit of oxygen. And we had to add one more thing to catch that oxygen. In this case, we're going to add a little bit of soap to catch our oxygen. So turning the hydrogen peroxide into water and oxygen caught by soap to get nice foamy bubbles. Are you all done stirring up all that yeast over there, Mr. Bond?
Stirring away.
All right, now if you're doing it at home, you don't want any clumps in there whatsoever. You want it to be nice and peanut butter textured. If it's really hard to get it all kind of liquidy, you can add just a little bit water, but you kind of want to be able to pour this out. So I guess it should be a little bit wetter than just regular peanut butter, right? Looking good over there?
Looking good.
Okay, good. So let's go ahead and take some of our soap. There we go. And we need a nice little bottle to put it in. And we need some of our hydrogen peroxide, our H2O2. So I'm going to start by adding that. Now, the next step, after I pour maybe a quarter cup down into the bottom, is I need to add that soap. Now, I don't want to add so much of this to where it ruins the experiment. Too much soap is no good. So just a little bit of a glug, maybe 5 drops at most is enough. And then I'm going to gently swirl it around. We call this the science swirl. If I shake it really hard, we can add extra soap bubbles that we don't actually want for this experiment. We want all of our yeast to be able to reach the bottom of this container really, really easily. Now, the last thing that before we pour our yeast in that's going to start our reaction is a little bit of our blue food coloring. It just makes it pretty, if you ask me. So that should be it. We should be able to get going, but before we do, I'm going to make it a little bit stronger. You see, we actually have this wonderful hydrogen peroxide, and this is what you're going to use at home, but you can actually go to the beauty store and make it a little bit stronger. Problem is, I don't want to get this on my hands, so I'm going to let him use his glove. All right. Now we're going to spike this just a little bit. This is going to make our reaction on camera hopefully just be all the prettier, but definitely we won't want to be touching it. This experiment at home for you all, though, if you don't use the stronger stuff, you can definitely play in this foam. So let's go ahead and see what we have here. Should we just pour it all in all at once? All right.
All right, ready?
3, 2, 1. Whoa! That is so cool. It's a perfect eruption.
That looks like the toothpaste I used growing up.
Ew. Wow, that's really cool. So they call it elephant's toothpaste, yeah, because the lines that you see with all the colors, it looks a lot like toothpaste. Obviously, we wouldn't want to brush our teeth with this. But we actually have a version that we did of this even bigger. We're going to go to Coco Bond outside where he's going to do a massive elephant toothpaste explosion.
Now we've got soap here. Pour it in there. This is just regular dish soap. Next we've got food coloring. Add a little color to this. And next we have hydrogen peroxide, 30%. That's why I've got the gloves and glasses on. We're going to clean up the table, get everything off of it. Excellent. Now we're going to pour our potassium iodide in there very quickly. Back away. Potassium iodide, our catalyst for this experiment.
It's alive! It's alive!
Now, as we can see, the experiment is steaming because it is producing heat. It is an exothermic reaction.
An exothermic reaction is a chemical reaction that releases energy as heat, such as combustion in an engine. An endothermic reaction takes in energy from the surroundings, like photosynthesis. Endothermic reactions tend to feel cold, while exothermic reactions can be very hot.
now we've got an even larger bottle. Everything's set up. We're just going to get going. This is a larger bottle with more concentrated potassium iodide. Because this has a skinnier topped bottle, it will actually erupt much higher. It's still releasing that oxygen from the hydrogen peroxide, and it will keep going until there's nothing left. Now, I think it's time that we supersized it. What do you think? We've got a larger bottle. Ugh, it's much heavier. We've got our hydrogen peroxide that we're pouring in. This will be crazy. You ready?
Well, that was a lot of fun.
Yeah, good job, Coco.
So I understand you did an experiment with volcanoes earlier this week, is that right?
Yes, we simulated the eruption of Krakatoa using ammonium dichromate. So let's go and take a look at
Yeah,
it.
let's watch that.
So about 150 years ago was the largest volcanic reaction in human history. And do you know what that was called?
Krakatoa?
Krakatoa, no, that's when you got out of bed last night and kicked the coffee table.
It really hurt. Honestly, really hurt.
Krakatoa, yes. It was an island near Indonesia, and when it erupted, the entire island was destroyed.
Gone? Completely?
Ships that passed in the next few years had Krakatoa on the map, and as they sailed by, there was no island. So that's how we got a recording of the fact that the island was completely destroyed.
That's crazy.
So we're going to do a miniature volcanic eruption here. Now we're inside, we don't have a hood, so we need to know that we're using safe chemicals. This is ammonium dichromate. It's an orange crystal.
It's really bright, isn't it?
Yeah, and we know that when it erupts, when it burns, the gases that are given off are steam, which is safe, as long as you don't get too close, and nitrogen, which is totally safe.
Makes up 70% of our air.
That's right. So we don't have to worry about the products of this reaction. The steam and the nitrogen are totally safe. They will be very hot, they'll be going straight up, but they're not going to be dangerous for us to inhale.
Of course.
So ammonium dichromate will burn just like a volcanic eruption. But they won't burn unless I put in some activation energy. You mentioned earlier, to start a reaction you need an activation energy. So I'm going to start the volcano erupting, but then it will have enough energy to continue by itself, a chain reaction.
Awesome.
So we're going to start the volcano erupting here. Steam is coming up in the air, you can see the steam. Ash is flying up in the air. About 2,000 years ago, Mount Vesuvius erupted just like this. Many people died, and it was the gases that were given off, the noxious gases that killed most of the people. And then the entire town of Pompeii was buried with this ash.
Just about last week was the 40th anniversary of Mount St. Helens. Did you know that?
Mount St. Helens, right.
Which is another volcanic eruption. Happened in the 80s.
And the volcano's finished erupting for another 2,000 years. Here's all the ash.
None of it's orange anymore. That's
No,
crazy.
this is an oxidation reaction. This is chromium oxide. It's a little bit like iron turns into rust. And that ash covered Pompeii for over 1,000 years.
Thank you guys for watching with us. If you want to do more at-home science experiments, check out our website, scienceguysofbaltimore.com.
Thanks for watching.